Assalamualaikum and hi everyone. My name is Muhammad Ikmal Hakim bin Muhammad Zamri. My metric number is A22A0400. Today I would like to present about assignment business statistics set D. We are from group 16. We have 6 group members, which is Raja Muhammad Arif, Azwaliza, Aisyah, Aufa, Muhammad Hafiz and me, Muhammad Ikmal Hakim. Firstly is 1.0 data descriptive. The objective of this study is to elucidate the critical factors and various fields or features present in the data collection. Our data set D encompasses information on sales comprise income, advertising, population, price, shelf log and age. In our study, the dependent variable is sales, while the independent variable are price and comprise. The data pertain to custard purchase, detailed further below the data. In section 5.0 of this study, SPSS software will be used for the data analysis. Through this program, manual computation result will be compared with SPSS result. The analysis which encompass a comparison of numerical and graphical data, and SPSS will be utilized to execute ANOVA as a step in the hypothesis testing. The study will investigate whether sales comprise income, advertising population price, shelf log, age, and urban impact the custard variable at the study conclusion. Next is 2.0, sampling data and recode categorical data. Sampling can be carried out through a probability-based approach using random number corresponding to point in the data set to eliminate correlation in the selected sample. Type of probability sampling include simple random, systematic, stratified, cluster, and multi-stage method. Alternatively, non-probability sampling rely on the analyst's judgment to determine an abstract data sample. Sample size indicate the number of participants or observation included in the study, usually represented as n. It affects two statistical properties, the precision of the estimate and the power of the study to draw conclusion. For this observation, the sample size is determined by using the last 2 digits of the largest metric number in the group, which is 97. Consequently, the largest 2-digit number from the student metric number A22A0797 is used as the sample size. That's all for me. I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aisyah binti Raisi. My menstrual number is A22A0797. I represent it to you 3.1 about the major or central tendencies. For this part, it has 3 measures, that is mean, median, and mode. We will use the formula as the provided to calculate these 3 measures based on 3 items, which is price, comprise, and sales. Based on the data, the mean price is 113.1, for the median price is 143.03, and the for mode price is 1.023. Besides that, for the comprise mean is 123.10, for the median comprise is 121.52, and for the mode comprise is 123.25. Lastly, for the sale means is 7.34, for median sale is 6.854, and for the mode sale is 7.292. That's all from me, and I will pass to the next presenter.
Hi, Assalamualaikum. My name is Aufa Mazrin Atasha binti Ruziman, matrix number A22A0411. Now, I want to present about measure of position. The measure of position is a statistical tool used to identify the location of a particular value or set of values in a dataset. This step helps in understanding the description of data and identify the spread and central tendency in a dataset. The 3 main measures of ranking are quartiles, deciles, and percentiles. The position of the first quartile is located at last intervals 80 until 99 by observing the value of cumulative frequency, while the position of the third quartile is located at class interval 120 until 139 by observing the value of cumulative frequency. The answer of first quartile is 99.17 and the third quartile is 129.69 respectively. Next, the interquartile range can be calculated by deducting the first quartile from the third quartile. To get in interquartile range, we need to calculate third quartile minus first quartile, and the answer is 30.52. So that the interquartile range is 31. Next is comprise. The position of the first quartile is located at class interval 105 until 119 by observing the value of cumulative frequency, while the position of the third quartile is located at class interval 120 until 134 by observing the value of cumulative frequency. The first quartile is 111.63 and the third quartile is 132.88 respectively. Next, the interquartile range can be calculated by deducting the first quartile from the third quartile, and the answer is 21.25, so that the interquartile range is 21. And the last one is sales. The position of the first quartile is located at class interval 4.50 until 6.69 by observing the value of cumulative frequency, while the position of the third quartile is located at class interval 8.90 until 11.09 by observing the value of cumulative frequency. Therefore, the first and third quartile are 5.21 and 9.28 respectively. Next, the interquartile range can be calculated by deducting the first quartile from the third quartile. The answer of our interquartile range is 4.07, so that the interquartile range is 4.
Hi, my name is Azwaliza Meti Azman and my metric number is A22A0495. I will present 3.3 measure of variation. For measure of variation, there are three often used parameters to measure the degree of variation in a set of random variables. They are range, variance, and standard deviation. First of all, we have range. A formula for range is maximum data entry minus with minimum data entry. Let's see in price. For example, price maximum data entry is 159 minus with minimum data entry is 24 and range in price is 135. The formula same goes to comprise and sales. Next, we have variance. For variance, we use same formula for price, comprise, and sales. For price, we got 560,809.29. For comprise, we got 614,592.17. And for sales, we got 1,677.276. The last one for measure of variation is standard variation. For the formula, we use square root variance. We use the same formula for price, comprise, and sale. For price, we got 748.87. And for comprise, we got 783.96. And the last one for sale, we got 40.955. That's all for me. I will pass to the next presenter.
Assalamualaikum and hi, my name is Muhammad Hafiz bin Amizu. My matrix number is A22A0329. Next, I will present for graphical representation. For your information, graphical representation is statistics aids in making complex information more accessible and understandable through chart, graph, and diagrams. It enhances communication and enable both expert and non-expert to understand key insight, compare values, draw a conclusion, and support decision-making processes. Let's get started without waiting any time. First, I will provide a visual representation of the price that our group creates. Our group decides to make a frequency polygon for the price. Based on the data, the graph on the slide, we can see the class interval 120 until 139 has the highest frequency of 54. This means that there are 54 data points falling within this range. In other words, 54 observations have values between 120 and 139. Therefore, the class interval 0 until 19 has the lowest frequency of 0. This indicates that there are no data points falling within this range. Second, I will provide a visual representation of the comprise that our group creates. Our group decides to make an OGIF for the comprise. With a frequency of 60, the class interval 120 until 134 is the highest one. This indicates that this range has 60 data points. Stated otherwise, 60 observations have values ranging from 120 to 139. The class interval with the lowest frequency of 0 is 0 until 59.5. This suggests that not a single data point falls into this range. It is important to remember that there is no observation frequency in this interval. Lastly, I will provide a visual representation of the sales that our group creates. Our group decides to make a frequency polygon for the sales. The class interval with the high frequency is 6.70 until 8.89 with a frequency of 43. This means that there are 43 observations in the data sets that are in the range of 6.70 to 8.89. The class interval with the lowest frequency is 13.30 until 15.49 with a frequency of 4. This indicates that only 4 observations in the data sets are in the range of 13.30 to 15.49. In summary, The highest frequency is associated with the class interval 6.70 until 8.89, with the lowest frequency is associated with the class interval 13.30 until 15.49. That's all our group does for graphical representation for our assignment. And then the next representative will take over.
Hi and Assalamualaikum. My name is Wajib Muhammad Arifini bin Wajib Nasib Muhammad Aisyam. My metric number is A22A0647 and I will present my part, which is 5.0 statistical analysis using SPSS. So the first one is 5.1, which is numerical discrete measure. So these both table are calculated by SPSS and do it manually. So this table provide a comprehensive overview of the statistical measure for three variables: sale, price, and comparative price, based on dataset of 150 observation. Next, we got 5.1.1, draw graph by using Excel software. So the first graph is the price of frequency by midpoint. From this graph, we can see that the x-axis represent the midpoint and the y-axis represent the frequency of the price group. The first point must be 9.5 midpoint with a frequency of 0. The last point must be at 169.5 midpoint with frequency of 150. So the next graph is a graph comprised of the frequency cumulative by upper class boundary. So from this graph, we can see that the x-axis represent the upper class boundary and the y-axis represent the cumulative frequency for the comprised group. The first point must be 74.5 upper class boundary, which is a cumulative frequency of the 0. The last point must be at 164.5 upper class boundary with cumulative frequency of 150. So for the last one of the graph, which is a sale of frequency by midpoint. So from this graph, you can see that the x-axis represent the midpoint and the y-axis represent the frequency for the sale group. The first point must be at 0.045 midpoint with a frequency of 0. The last point must be at 16.95 midpoint with frequency of 150. So we move on to 5.2 hypothesis testing. 5.2.1 one sample t-test. So for making this test, we made 5 steps. So step 1 is null hypothesis and alternative hypothesis. H0 equal mu 150 less than 9 and H1 mu 150 greater than 9. So step 2, level of significance, A equal 0.05. Step 3, computer testing. We do T at T equal bracket x bar minus mu 0 close bracket divided bracket s divided square root and close bracket, where x bar is the sample means, mu 0 represent the population mean, and S is the standard deviation of the sample and N stand for the size of the sample. So T equal 6.5156. So step 4 is decision rule. N equal 150, DF equal 149, A equal 0.05, critical value is 9. So we move on to step 5 is making a decision. So based on all the step, we reject the null hypothesis because the critical t-test is less than the value of t-test SPSS 6.5156. So 5.2.2 is ANOVA table sale. If the alpha level, significant level is set at 0.05 and the p-value obtained from ANOVA analysis is 0.000, it means the p-value is greater than alpha level. Therefore, the result will be considered not statistically significant in this case. We would fail to reject the null hypothesis, which suggests that there is no statistically significant difference in means of the various level of the cell variable. If the alpha level, significant level, is set at 0.10 and the p-value obtained from the ANOVA analysis is 0.000, it means that p-value is lower than the alpha level. Therefore, the result will be considered statistically significant. In that case, we would reject the null hypothesis, which suggests that there is the statistical significant difference in means of various levels of the cell variable. So we move on to the 5.3, which is a correlation analysis. So based on the visual I provide, Correlation analysis reveal the important insight into the relationship between sale price and comp price. There is a significant negative correlation between sale and price. R equal negative 358, P equals 0.000, indicating that when price increase, sell tend to decrease. So we move on to 5.4 confidence interval. So the case processing summary. By using the SPSS, we collect the result of the 95% confidence interval. The standard error of the sale is our dependent variable, which is 0.23948. Beside that, it can be said that 95% confident that population parameter is between 6.9635 and 7.9097. So the last one we got is 5.5 prediction modeling. So the first one we got is a variable enter or remove. The variable enter into the model are price and comp price. Method used is enter, meaning our predictor are enter into the model in one step. This multiple liner regression as there are two independent variable. Next is a model summary. Our multiple correlation coefficient is 0.608, indicating a moderate positive relationship between predictor and dependent variable. R square value of 0.370 suggests that approximately 37% of the variance in sale can be explained by price and comp price. Adjusted R square 0.362 is slightly lower, adjusting for the number of predictor in the model. So next we got the ANOVA table. The F statistic 43.199 with a significant level less than 0.001 indicated that at least one predictor variable has a significant relationship with the dependent variable, which means sales. It tests the null hypothesis that multiple out equals 0, meaning no linear relationship exists between predictor and dependent variable. Next, we got a coefficient table. Constant term is 4.610. This is where sale would be expected to start when both price and comp price are 0. Coefficient for comp price 0.107 indicated for each unit increase in comp price. Sale increased by an estimate 0.107 unit, assuming price remain constant. Coefficient for price negative 0.091 suggests that for each unit increase in price, sale decreased by an estimate 0.0191 unit, assuming comp price remain constant. So based all of that, the data sample set, the equation we can do is y equal 4.610 minus 0.091 multiple 1 plus 0.107 multiple 2. Here y can be the number of chai car seats sold in thousand. X1 can be the price of the car seat and X2 can be the price of the competitor car seats. The equation is a sale equal 4.610 minus 0.091 price plus 0.107 comp price. Based on the standardized beta coefficient, the effect of comp price is 0.575, which is about 6 times 0.575 or 0.093, 6 higher than the effect of price 0.093 in magnitude. The p-value for price is 0.000, which is less than 0.05. Thus, the price is a significant predictor of sale. The p-value of the comp price is also 0.000, less than 0.05. Hence, comp price is also a significant predictor. So that's all from me. I will pass to the next presenter.
In conclusion, all of the statistical computations required for this report can be complete using the information we learned from the lecture. A 150 sample dataset with 3 fields, price, comp price, and sales was used. To complete the graphical representation, we also calculate the class interval, frequency, cumulative frequency, relative frequency, pie chart, midpoint, upper boundaries, and lower boundaries. Additionally, we use a variety of numerical descriptive measures to characterize the dataset. These include measures of central tendency, position and variation for a single variable that the class group manual calculates, and the SPSS system for price, comprise and sale. We also employed the ANOVA table and one sample t-test for hypothesis testing.